Okay, this is SMAA support session for the summative assessment. I'm going to take you through what's expected for this assessment. So I'm going to share my screen. All right, for the theory questions, I won't be going through that. I think that's very straightforward, and that just requires reading on the student's part. So I'll focus more on the questions that require calculations. All right, so with question 2, what you're asked to do is to create 5 folds and you have 30 observations. So if you have 30 observations and you have 5 folds, then you need to divide your observations equally into each fold. So for instance, you would have 1 to 6 observations in fold 1, then the next 6, which is 7 to 12, that will fall into fold 2, etc., etc., all the way to the last fold where you have 25 to 30, all right, because you only have 30 observations. So in each fold, you will have 6 observations. Now, at each iteration, each of these folds will have a chance to be the test set, right? Or in other words, be the unseen test set where you don't train the model on that. So for instance, if you on iteration 1, you could let fold 1 be the test. So this could be your test for iteration 1, and then the rest of them will be your training set. For iteration 2, you could make fold 2 your test set, and then the rest of them are your training set. All right, so at each iteration, every fold will have a turn to be the test set. All right, so that's how you create your iterations. Now, at each of these iterations, you need to fit a logistic regression model in Excel. So if you're not sure how to do that, I'm going to refer you to the support session for assignment 2, where I showed you how to fit a logistic regression model. There's also a masterclass session on that, so you can refer to that if you're not sure how to fit a logistic regression model. All right, so please refer to that. A note on this question is that you need to show your workings and how you fit the model, and you need to show the model performance for each of these iterations. All right. Okay, so how it performs, like how its predictions compares to the actual amounts, and you need to use the relevant metrics for performance. All right, so read the question and just provide that information. Okay, so that's question 2. Okay, so I'm going to move to the next question. All right, question 3 is theory, so I'm also not covering that. Okay, I'll leave it for the student to go over that. We have question 4. Now that deals with rules of probability and specifically Bayes' theorem. Okay. Now, there's 2 probability rules you specifically need to tackle these problems. All right. The first one is if you have an event B, okay, that can take on 1 to all the way to k possible outcomes. So let's simplify it. Instead of k, let's say it can only take a yes and no outcome. So that means it'll only stop at 2, okay, because it can take on one possibility, which is yes, the other possibility, which is a no. So it's only 2 possible outcomes. But I'm just giving you the general definitions. If you can take on more than just 2 outcomes, let's say you can take on k possible outcomes, then if you wanted the probability of, say, a equals to some small a, right now, you can think of a being another event where a can take on a yes or no, right? So a can take on a 1 or 0. I have a small a to represent one of those events. So if you wanted the probability of a equals to small a, it's given by this formula here. Okay. We use conditional probability rules to find that. Now, in this question, you need to figure out what events to substitute for your A and B, all right? So this equation will come in handy, right? You just need to know how to use it. And obviously, I'm not going to show the exact events for the question to substitute because that's giving you the answer. You need to apply yourself to use this equation. All right, and then the other theorem that you will use in this question is Bayes' theorem. You don't need to prove it, you just need to know how to use it. All right, so this is Bayes' theorem. Probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. And you, once again, need to determine what events are going to be your A and B. Look at the question. You have something in terms of a pass and something in terms of whether a student has studied. So you need to determine what you need to substitute for A and B regarding the pass and the studied. Okay. All right, so that's all I'm going to say about that. You need to know how to apply these equations to get the answer. All right. Okay, so that's question 4. Question 5, right? So question 5 boils down to you actually just using the formulas that are given to you and knowing what values to substitute into them. So the one formula that's given to you is this formula here. Let me use a different color to draw your attention to that. All right, so the one formula is this, and this formula gives you your weights. All right, so if we started looking at what's given to us, we're given this table, all right? We have 4 rows, and the I just represents the row, or you can think of it as the observation. Okay, so the first row is observation 1, the second row is observation 2, etc. You have an xi value for each observation, which is given to you, all right? That's the middle column, it's given to you, and the last column is also given to you. You're given a corresponding y value for each observation in the table. Now, what you need to do is basically create a column of weights, W's, and you're going to have a value for each row. And how you get the value for each row is by using this equation. Now you have all the values to use in this equation. It's given to you in your table and in the question. You're also given this additional piece of information here. X is equal to 3 and H is equal to 1. So you have these values to substitute into that formula and you'll get a weight value for each row. Now, once you have that, then you can move on to the next step, which is using this equation. And this equation will give you the answer, the final answer. So once you have your weights, your W's, you have your Y's, which is in the table already. You need to substitute that into this equation and you'll get your predicted Y value. Okay, so it's a matter of you having to apply yourself using the data that's given and use it into this equation correctly. All right, so this question tests your ability to do that. Okay, so I'm not going to do it with a mock data set because that's just going to be simply you substituting values to what's in the summative and getting the answer. So I'm doing it this way because you do need to apply yourself for this exam. All right, so that's how you use these equations to get to your answer. All right, so that's question 5. Okay, let's move on. Okay, now question 6, there's a lot more calculations here, and I'll take you through this. This one, I will use a dummy data set, right? It won't be the same dimension as what it is in the exam, but you need to apply your mind to it. You can use this kind of methodology to the exam, all right, to get to the answer. So here in my case, suppose I have a matrix with 3 observations, so 3 rows, but I have 2 variables or 2 features. So my 2 features are x1 and x2. Okay, the first column is x1, the second column is x2. And these are the values for x1 and x2. So x1 takes on 1, 4, and 7 for each of the observations, and x2 takes on 2, 3, and 7. Now each of these columns has a mean, which you can work out Okay, it's easy to work out the average, and you can work out the standard deviation for each of these columns. I've done it below the columns here. Okay, so I've listed it here. Here's my standard deviation for each of these columns, and here's my average, my mean. All right. Now, once I have that, I can standardize each of the x values, right? To standardize them means I need to convert it to a z value, and I would need to use the standardization formula given by this. So I just take each x value, subtract its mean, and divide by the standard deviation, which I already have listed here. So if I do that for the first one, the first x value is 1. So if I subtract its mean, which is 4, right? Its mean, which is 4. So it's 1. You look here, 1 minus 4 divided by the standard deviation, which is 3. That gives me minus 1. So that's how I get this first element. That's my first z value. All right, so I need to do the same thing for all of these x values to get the corresponding z values. So once I have that, now I don't have a column of x1 and x2. I have a column of z1 and z2. So the standardized equivalent values. So once I have that, I need to use the formula for the covariance. Now the formula for the covariance is given by this. Right? You're not expected to memorize it. You can always just look it up. But this is the formula for the covariance. So what it is, it's simply just telling you over all the observations. In our case, we have 3 rows, right? So for all 3 rows, you take each value in your x1 column and you subtract its average. Right? You subtract its average and then you square the result. And then you multiply it by each x2 value multiplied, each x2 value subtracting its mean and squaring it. And then you divide by the number of observations, which is 3 minus 1. Okay, because that's what your n is. Your n is the number of rows that you have. Okay, so you're gonna use this formula to actually get the covariance. But things have been simplified for you because if you've already standardized your x values to a z value, you don't need to do the covariance in terms of x1 and x2. You can do it in terms of z1 and z2. And that is handy because if you remember, when you standardize a variable, they have a 0 mean. So when you ever use this formula here to get the equivalent z score, the mean of the z score is now going to be 0. So because of that, when you're standardizing z1 and z2, and when you're doing the covariance matrix for that, this mean drops off because it's 0. So you just have z1 squared times z2 squared. So if anything you want to take away from this is when you calculating your covariance matrix, use this formula here instead. Okay, you don't need to use this formula here because you've already standardized it. So you use this formula here, and we're going to calculate the covariance matrix. So let me just go to the next page, and I'll show you how we're using this formula for this example. Now, this is the formula I highlighted in the previous page. All right. So I need to calculate my covariance matrix. Now, each element in that covariance matrix is given by the first element is just the covariance of Z1 and Z1. The next element is the covariance between Z1 and Z2. Third element is the covariance between Z2 and Z1. And lastly, Z2 and Z2. All right, that's the fourth element. So you need to calculate each of them. Now, each of them, you use this formula to do it. All right, your Z1 and your Z2 is given here. There it is. This is your Z1 column. This is your Z2 column. So you have the values you need to feed into this equation here. And once you can do that, you can calculate each of these elements of this covariance matrix. If you do that, you'll get this matrix here for my data. Okay, 1 in the diagonal, and these are the values on the off-diagonal elements. So this is my covariance matrix. I represent it by sigma. All right. Now, finally, to get the eigenvalues, you need to subtract lambda from the diagonal. So I take the same matrix that I have here, my covariance matrix. All I do is I subtract lambda from the diagonal, which is why I have this. And then I find the determinant. You find the determinant of this matrix, okay? And you equate it to 0, and then you solve for lambda. So you find the determinant. The determinant is given by this equation, okay? Please, you should be familiar with how to calculate the determinant. If you're not, look it up. Okay, you're going to be doing it for a 3x3 matrix instead. Just give me a second. I think I may have sharing. Okay, coming back to what I was saying. All right, so you need to calculate the determinant of this matrix after subtracting lambda from the diagonal. You equate it to 0, and then you solve for lambda. And the solutions you get for lambda, and in this example, I get 1.9449 and 0.0551. These are my eigenvalues. All right, so to reiterate, you start off with your matrix of X columns. You need to standardize it and get a Z matrix, all right? You'll have the same number of columns as you had for your X matrix, but now each column will be Z1, Z2, etc. Then you use the values in your Z matrix to calculate the covariance using this formula here, right? So if you had Z1 and Z1 instead of Z2 here, you just replace this with Z1, all right? And you would need to do that if you're going to calculate this first element here, all right? Here, remember, if you get this element here, all right, this matrix it's symmetric, so that the off diagonals will equal each other. So if you only calculate this one, you don't need to calculate the other one. In other words, what I'm saying is the covariance of Z2 and Z1 will be the same as the covariance of Z1, Z2. Okay. So once you get your matrix, right, you then need to subtract lambda from the diagonal. You then calculate the determinant here. You equate it to 0, and you solve for lambda. And the solutions for lambda will be your eigenvalues. All right. Okay. So that's all the questions for the summative. Okay. Hopefully this gives you some direction and how to approach it. Yeah. And I'll make this recording available. All right. All the best.